All right, today we're going to be working with graphing story problems with quadratic equations. Now, the good news is you don't have to create the equations, they are already created for you. All you have to do is answer the questions and graph them. So, we're building off of that concept. So, during a football game, the kicker was kicking a field goal. The football's path is modeled by the equation y equals negative x squared plus 12x, where y is the height of the football in feet after x seconds. Determine the maximum height of the ball. We know that this is going to be a maximum because it has a negative value in front of x squared. So that's why we know it's going to be a maximum. So if you remember back a few days ago when we were graphing equations, whenever we are to find the maximum height or the vertex, we have to find the axis of symmetry first, which is x equals the opposite of b over 2a. So the opposite of b, remember our equation is y equals negative x squared plus 12x. So this is our a and this is our b, the values. So b will be negative 12 and then our a value is negative 1. So we have negative 12 over negative 2, which simplifies to 6. Remember, x stands for seconds. So that is how long it's going to take to get to the maximum height of the kick or the ball in the air. But we asked for what is the height, not how many seconds does it take to get there. So since we know that it takes 6 seconds to get to the maximum height, we are going to plug in 6 for our x value. So we get negative 36 here plus 72, which gives us 36, and remember in feet. So feet, 36 feet. All right. Now down here it says that determine the height of the football after 5 seconds. So this is where that number sense idea from NWA comes into play. If I know that after 6 seconds it's at its maximum height of 36 feet, I know that after 5 seconds it has to be less than 36. So when I plug in 5 for my x value, if I do not get a number that is less than 36, I did something wrong. So 5 squared is 25 times negative 1 is negative 25 plus 60. So I end up getting 35 feet, which that is less than 36 feet. So I am good to go. Then my last one here, it says, how soon will the football hit the ground after going through the goalpost? So the ground is a height of 0, which means height is our y value. So when we have the equation y equals negative x squared plus 12x, my y is going to be 0, and I'm trying to figure out what x is. So when we go back to before this part, so in April, we were working on solving quadratic equations. Remember, we can solve by factoring. So I'm going to factor out a negative 1x from the first term, which will leave me with a positive x. And I'm going to factor out a negative 1x from the 12x. So that'll be negative 12 that I'll be left with, and that is equal to 0. So in order to solve this, I set them both equal to 0 and solve. So I divide by negative 1. So I get x equals 0, and then over here I get x equals 12. Well, I know that the only one that makes sense for this is that it has to go from 0, 0 on the ground up into the air and back down. So the 0 seconds makes no sense at all because I know that it took me 6 seconds to get to the maximum height. So it's actually going to take me 12 seconds to get back down to the ground, the ball, once it's kicked in the air. And this is logical because it took 6 seconds to get to the height, so it's going to take another 6 seconds to go down. All right, so now we're going to actually graph this. So I already technically have 4 ordered pairs. I have 0, 0 and 0, 12, 0, 0 and 12, 0 from part C. I have 5, 35 from part B, and from part A, I have 6, 36. So I'm going to graph those ordered pairs right now. I have 0, 0. I have after 5 seconds, it's going to be at 35 feet. So right here. At 6 seconds, it's going to be at 36. and then I know after 12 seconds it's going to be at 0 again. Now I could simply just graph and go like that, and yay, I have my parabola. I'm not going to give you full credit for that. I know that this is my axis of symmetry here, which means I have to have equal number of points on each side. I also know that because this is 1 away, I know that this is also going to be 1 away. So I already know another value that are equal. Alright, so I'm going to erase that and erase that. Okay, so now I'm going to create a table over here of x and y values so that it makes it a little easier for me to graph. Okay, sorry, that's my husband yelling, not paying attention to me recording. Alright, so I know that I have values at 0, I have values at 5, 6, and 12. So what I'm going to do is I'm going to plug in values for x at 1, x at 2, x at 3, and x at 4. And the reason I'm doing all of that is because then that gives me my whole left side of the graph. And then I am also going to be able to determine my right side of my graph. Because if at 1 it's at 5 feet, then also at 11 it's going to be at 5 feet, because they have to be equal distant from our axis of symmetry. Alright, so -1 times 1 squared is going to give me -1, plus 12 times 1 is 12, so -1 plus 12 is 11. So I know 1, 11 is going to be right here. That means 11, 11 is going to be right here, because they are equal distant from the axis of symmetry, meaning that they are 5 away and 5 away. Okay, number 2, when I plug that in, 2 squared is 4, times -1 is -4. So, and then 12 times 4 is 48. So -4 plus 48 is going to give me I did something wrong there. Am I using the right equation here? Oh, I plugged in 4. There we go. Sorry. Okay. So I knew that when I got 44 that was too big because that's greater than my vertex, and I was like, something's wrong. Alright, so 2 squared is 4, times -1 is -4. 2 times 2 is 24. So -4 plus 24 is going to give me 20. So I know that at 220, that is a value. I also know at 1020, that is a value. Then for number 3, when I plug that in, I would get -9 squared plus 36. So -9 plus 36 is going to give me 27. So 327 is right here, which means I'm going to have 927. And then my last value here will give me -16 plus 48. And -16 plus 48 is 32. So 4 and 32 is going to be right here, which also means that 832. So now I have a perfect parabola to graph here. And remember that when you are graphing parabolas, that they have that gentle curve. They do not have a point. This is not absolute value. All right, if you do want to pause this to be able to do your next problem by yourself, go ahead. The notes are in Canvas. Or if you just want to follow along, you can go ahead and do that and not pause. All right, so if you did pause, welcome back. If you didn't, here we go. So during a round of golf, the golf ball's path is modeled by the equation y equals -x squared plus 20x, where y is the height of the golf ball in yards after x seconds, to determine the maximum height of the ball. So to do this, we have to go with finding our axis of symmetry first. So our b value is already positive, so it's going to be -20 over 2 times -1. So -20 over -2 is +10. So after 10 seconds, that is where the highest point of the golf ball. So now I'm going to plug that in to my equation. So 10 squared is 100. So I have -100 plus 200 gives me 100 yards. So that is how far it's in the air, not that it went 100 yards distance-wise. It means from the ground, it's 100 yards in the air. So for our next one here, it says after 8 seconds. Well, I know that after 10 seconds, it's at 100 yards. So if my answer is not less than 100, I know I did something wrong. Here we go. Y equals negative 1 times 8 squared plus 20 times 8. So I have negative 64 plus 160. If I add those together, I end up getting 96 yards, which is less than 100. So I know that I have that at least reasonably correct. And then my last one here, let's do it in purple. All right, so how soon will the ball hit the ground? Remember, ground is when y equals 0. So in my equation, I'm going to have 0 equals negative 1x squared plus 20x. So we're going to, again, factor out a negative 1x, which means divide it. So negative 1x squared divided by negative 1x is going to give me positive 1x. And then negative 20x divided by negative 1, or 20x divided by negative 1x is going to give me negative 20. So now I'm going to set these equal to 0 and solve them. So x equals 0 and x minus 20. So we know that the 0, 0 isn't the correct option in this case because we know that it's going to take more than, it's going to take more than 0 seconds to go up and down. So hit the ball and then land again. We also know that 20 seconds is reasonable because it took 10 seconds to get to its peak, so it's going to take another 10 seconds to settle at the bottom. All right, so I already know some of my points, just like I did last time. I know 0, 0. I know 20, 0. I know that my axis of symmetry is at 10, 100. My axis of symmetry, is at 10. My vertex is at 10, 100. I also know that after 8 seconds, it's going to be at 96 yards. So 8 and 96, which means that also at 12 seconds, it's going to be at 96 yards. All right. So again, I'm not going to do every single value that I possibly have, but I am going to do the values of 1, 3, 5, and 7, just so I can get a little bit better understanding as to what my graph is going to look like. And because of that, I'm going to also be able to determine other values on the other side of my axis of symmetry. And this is y equals negative 1x squared plus 20x. So like I said, I'm going to use the values of 1, 3, 5, and 7. That also means that I am using the value of 19 here for 1. When I do 3, that would be 17. When I do the value of 5, that would be 15. And when I do the value of 7, that would be 13. And I already have my values of 8 and 12, so I pretty much have covered every point without doing every single point. All right, so when I plug this in, I'm going to get negative 1 plus 20, and negative 1 plus 20 is 19. So 1, 19, and 19, 19. All right, so now when I plug in 3, I'm going to have negative 9 plus 60. So that's going to give me 51. So set 3 and 51, and then also 17 and 51. There we go. So when I plug in 5, I'm going to get negative 25 plus 100. So that's going to give me 75. So at 5, I'm at 75. And at 15, I'm at 75. Here's my last one. 7 squared is 49 times negative 1 is negative 49 plus 140. So that's going to give me 91. So at 7 and 91, and then at 13 and 91. And then I'm going to connect them with that gentle curve. All right, so there's my parabola of hitting a golf ball. It'll take about 20 seconds to hit the ground. Remember, with a golf ball, though, it continues bouncing, so it's almost like it goes choo, 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 and it keeps going. You don't need to do that part with the parabola, though. I hope this helps you, and remember, on Tuesday, we're going to be working on the story problem practice. So if you have questions, please ask. If you need help, let me know. Have a good